Welcome to the Walton Pi. Today we're going to be talking about the chain rule. So why is the chain rule necessary? Well, let's suppose that we wanted to take the derivative of 2x plus 5 cubed. If we were to only use the power rule, because we have a cubed, then the derivative would be 3 times 2x plus 5 squared, which would be 12x squared plus 60x plus 75 if we expanded it all out. But if we expanded first and then took the derivative, we would get 24x squared plus 120x plus 150, which is definitely not the same answer as what we've got using only the power rule. So the chain rule is how we're able to combine these and not have to expand out every single time. So the chain rule is basically just going to give us the rule of if you have multiple functions nested inside each other, how do you take that derivative? So if we assume that g is differentiable at x and f is differentiable at g of x, then the function f of g of x is going to be differentiable at x, and the derivative is as follows. The derivative of f of g is going to be f prime of g times g prime of x. So it's derivative of the outsidemost function of the inside piece, where we didn't change the inside at all. Then we multiply it by the derivative of the inside piece. So going back to our starting example, we had 2x plus 5 all cubed, so our outsidemost function is something cubed, and our inside function is 2x plus 5. So the derivative of our outside function is x cubed, so that would go to 3 times the inside squared, so we have a 3 times 2x plus 5 squared. Then we multiply by the derivative of the inside, which in this case is 2, so our answer is going to be 3 times 2x plus 5 squared times 2. So let's go through an example. What is the derivative of x squared plus 3x minus 2 all cubed? Well, we have an outsidemost function, something cubed, and we have an inside function, x squared plus 3x minus 2. So the derivative of the outsidemost function is 3 times the inside squared, and then the derivative of the inside function is 2x plus 3. So the derivative is 3 times the inside squared, so 3 times x squared plus 3x minus 2, all squared, multiplied by the derivative of the inside, which is 2x plus 3. Let's find the derivative of sine of x cubed plus cosine of x. This is an example of one where we can't expand it and why we need to have the chain rule in order to even approach this sort of problem. Well, our outsidemost function is sine of something, and our inside function is x cubed plus cosine of x. So the derivative of our outsidemost function is going to be cosine of the inside, and then the derivative of the inside function is 3x squared minus sine of x. So the derivative is cosine of the inside, cosine of x cubed plus cosine of x, multiplied by the derivative of the inside, 3x squared minus sine of x. Now this is a process that can be nested as many times as we needed. We could have f of g of h and so on, and you're just going to continue to pull off the derivative of the outsidemost function at the time and leave the inside as it is, and then multiply by the derivative of the inside. I hope this video was helpful. Please check out my next video where I'll be going through some examples of the chain rule. Please like and subscribe if you haven't already so that you don't miss any of these other videos and so that I can continue to make them. Thank you very much and have a good rest of your day.